Chapter 1. Factors and Multiples. Factors. A shopkeeper has to display 12 bottles of ghee in his shop. He can arrange them in different ways. He can arrange them in one row. One row of 12 bottles, or 1 into 12 is equal to 12. He can arrange them in two rows. Two rows of 6 bottles, that is, 2 into 6 is equal to 12. He can arrange them in 3 rows. 3 rows of 4 bottles, that is, 3 into 4 is equal to 12. Here, 1, 2, 3, 4, 6, 12 are all factors of 12. When numbers are multiplied, they give the product. Each number which is multiplied is the factor of the product. Determining factors of a product. When a number divides another number exactly, then the divisor is called factor of the dividend. Let's take a number, say 30. Divide the number by 1, 2, 3, etc. 30 divided by 1 is equal to 30, or 1 into 30 is equal to 30. 30 divided by 2, or 2 into 15 is equal to 30. 30 divided by 3, or 3 into 10 is equal to 30. 30 divided by 4, not possible. Hence, 4 is not a factor of 30. 30 divided by 5 is equal to 6, or 5 into 6 is equal to 30. 30 divided by 6 is equal to, stop, because we have already found 6 as a factor of 30. So, 1, 2, 3, 5, 6, 10 and 30 are all factors of 30. We can build a product using more than 2 numbers. All the numbers used to build a product are the factors of that product. Examples: 3 into 5 into 7 is equal to 105. Hence, 3, 5, 7 are factors of 105. 2 into 5 into 11 is equal to 110. Here, 2, 5, 11 are factors of 110. When we divide a number by another and there is no remainder, then the divisor and the quotient are factors of the first number, that is dividend. Example 1. Find all the factors of 36. Solution. We have 1 into 36 is equal to 36. 2 into 18 is equal to 36. 3 into 12 is equal to 36. 4 into 9 is equal to 36. 6 into 6 is equal to 36. Thus, all the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Example 2. Is 9 a factor of 207? Solution. Let's divide 207 by 9. Thus, 9 divides 207 exactly. Hence, 9 is a factor of 207. Properties of factors. It is a factor of every number. Clearly, 1 divides every number exactly. For example, 16 divided by 1 is equal to 16. 13 divided by 1 is equal to 13. Every non-zero number is a factor of itself. Clearly, every non-zero number divides itself exactly. For example, 7 divided by 7 is equal to 1. 29 divided by 29 is equal to 1. Every non-zero number is a factor of 0. 0 divided by 5 is equal to 0. 0 divided by 15 is equal to 0. Thus, every non-zero number divides 0 exactly. Every number other than 1 has at least 2 factors, namely 1 and the number itself. Examples: 1 into 15 is equal to 15. 1 into 256 is equal to 256. The factor of a non-zero number is either less than or equal to the number. The smallest factor of a number is 1. The largest factor of a non-zero number is the number itself. Test of divisibility. We know that a number is said to be divisible by another number if on dividing it leaves no remainder. This process may sometimes be lengthy. To avoid the lengthy process of division, we follow some rules of divisibility. Let's study these rules. Test of divisibility by 2. All even numbers are divisible by 2. So 2, 4, 6, 8, 10, 12, etc. are divisible by 2. An even number has an even digit in its ones place. So we find that a number is divisible by 2 if it has an even digit or 0 in its ones place. Examples: 92, 78, 186, 310, 944, etc. are divisible by 2. Test of divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Let's check the divisibility of following numbers by 3. 21. 2 plus 1 is equal to 3. Sum is divisible by 3, so 21 is divisible by 3. 501. 5 plus 0 plus 1 is equal to 6. Sum is divisible by 3, so 501 is divisible by 3. 285. 2 plus 8 plus 5 is equal to 15. Sum is divisible by 3, so 285 is divisible by 3. Test of divisibility by 5. A number is divisible by 5 if it has either 0 or 5 in its ones place. For example, 35, 70, 345, 71,560 are all divisible by 5. But 92, 293, 41,732 are not divisible by 5 because they have digits in their ones place other than 0 or 5. Test of divisibility by 10. A number is divisible by 10 if the digit in its ones place is 0. For example, 20, 40, 760, 950, 1130 are all divisible by 10 because they all have 0 in their ones place. Building factor trees. Factor tree is built by taking the given number as its root. The circled number can be further broken up. We stop when we need to use 1 as a factor. Example 3. Make factor trees for the following: 63, 60. Solution. Common factors. Find out the factors of 18 and 15. Factors of 18. 18 divided by 1 is equal to 18. 18 divided by 2 is equal to 9. 18 divided by 3 is equal to 6. 18 divided by 9 is equal to 2. 18 divided by 18 is equal to 1. Factors of 18 are 1, 2, 3, 6, 9, 18. Factors of 15. 15 divided by 1 is equal to 15. 15 divided by 3 is equal to 5. 15 divided by 5 is equal to 3. 15 divided by 15 is equal to 1. Factors of 15 are 1, 3, 5, 15. 1 and 3 are common factors of 18 and 15. Example 4. Find out the common factors of 20 and 24. Solution. Factors of 20. 1, 2, 4, 5, 10 and 20. Factors of 24. 1, 2, 3, 4, 6, 8, 12 and 24. Common factors 1, 2, 4. Multiples. Multiples of number can be determined by multiplying that number by 1, 2, 3, 4 and so on. Example 5. 7 into 1 is equal to 7. 7 into 2 is equal to 14. 7 into 3 is equal to 21. 7 into 4 is equal to 28. 7 into 5 is equal to 35. Thus, 7, 14, 21, 28, 35 are all multiples of 7. Example 6. Find out the first 5 multiples of 3. Solution. 3 into 1 is equal to 3. 3 into 2 is equal to 6. 3 into 3 is equal to 9. 3 into 4 is equal to 12. 3 into 5 is equal to 15. Therefore, the first 5 multiples of 3 are 3, 6, 9, 12 and 15. Example 7. Is 39 a multiple of 6? Solution. The number 6 does not divide 39 exactly. Hence, 39 is not a multiple of 6. Example 8. Is 154 a multiple of 11? There is no reminder, therefore 154 is a multiple of 11. Example 9. Is 419 a multiple of 13? Solution. 13 does not divide 419 exactly. Therefore, 419 is not a multiple of 13. Properties of multiples. Every number is multiple of 1. We know that 1 is a factor of every number. Every non-zero number is a multiple of itself. 7 into 1 is equal to 7. 13 into 1 is equal to 13. 135 into 1 is equal to 135, etc. Thus 7 is a multiple of 7. 13 is a multiple of 13. 135 is a multiple of 135. 0 is a multiple of every non-zero number. We know that every non-zero number is a factor of 0. Therefore, 0 is a multiple of a number. Every non-zero multiple of a non-zero number is either greater than or equal to the number. For example, the smallest non-zero multiple of 7 is 7. The smallest non-zero multiple of 15 is 15, and so on. Common multiples. A number that is a multiple of 2 or more numbers is called a common multiple. Let's consider the first few multiples of 4 and 6. Multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36. Multiples of 6. 6, 12, 18, 24, 30, 36, 42. We can see that the numbers 12, 24, 36 appear in both the list of multiples. So they are the common multiples of 4 and 6. Let's see the common multiples of 2 and 3 on the number line. Multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. Multiples of 3. 3, 6, 9, 12, 15, 18, 21. The common multiples of 2 and 3 are 6, 12, 18. Even and odd numbers. The numbers that have 0, 2, 4, 6, 8 in their ones place are even numbers, or we can say all multiples of 2 are even numbers. The numbers that have 1, 3, 5, 7, 9 in their ones place are odd numbers. Odd numbers cannot be exactly divided by 2. There will always be a remainder of 1.